Hello, and welcome to my video on the January 2019 Algebra 2 Regents, question number 9. In this problem, we are asked which representation of a quadratic has imaginary roots, and the quadratic functions are presented in different forms. So I'm going to start with choice number 3, which has a graph as a quadratic, and you'll notice there is an x-intercept to the quadratic at x equals to 3, and also it's bouncing. Now, the solution to the roots here would be that x equals to 3 should be counted twice. And both those are real solutions, not imaginary, so choice 3 is not an answer. In choice 1, we see here there are two places where we see y is equal to 0. And the x values to both these y values of 0 are these solutions. But both of those solutions are real numbers. -2, -0.5 are real. They're not imaginary. So choice 1 does not have imaginary roots. In particular, for there to be imaginary roots, algebraically, if we solve, we should see the solution of I in our answer. So if we go to the equation in choice 2 and try and solve for x, let's see what happens. Let's see if we get I. To do that, we should first divide both sides by 2. We would then have x plus 3 being squared equaling to 32. To then get rid of the squaring, we could square root both sides, and we would get x plus 3 equaling, and you have to remember, technically we should have plus or minus square root 32 on the right side, and then to finish off solving for x, we would subtract 3 from both sides, and we would have x equaling -3 plus or minus square root of 32. But you'll notice in this final solution here, there's no I, so technically choice 2 is not the answer. Choice 4 is going to be the answer, but let's see where the imaginary roots come. If we try and solve for x, we would do that perhaps by subtracting 32 from both sides. We'd have 2x squared equaling -32. We would then divide both sides by 2, and we would get x squared equaling -16. And now when we take the square root of both sides, and again we'd want to have plus or minus square root on the right side, but because of the negative underneath the square root, we know that we can get rid of that by pulling out the I in front, and technically the final answer here would be x equals plus or minus for I, but there's our I. There's our imaginary root, and that's why choice 4 is a solution to this problem that has a quadratic with imaginary roots. So I hope this video helped you out, and good luck with all your studies. Thank you for watching, and take care.